Although air travel is the safest means of transportation in the world, aircraft still might overrun the runway during the period of taking off and landing due to pilot error, mechanical failure, and adverse weather, some with disastrous results. To avoid the severe consequences of runway overruns, the International Civil Aviation Organization, ICAO, stipulates that at least 90 meters runway and safety area, RASA, shall be set beyond the taking off and landing strip. Statistics show that 90 meters won't be enough to minimize the danger, so ICAO recommends setting a 240 meters RASA whenever possible. If doing so is restricted by natural obstacles, rivers, lakes, deep ravines, or constructions, or the cost is prohibitive, Engineered Material Arresting System (EMAS) can be an alternative measure for those airports that cannot expand their RASA to 240 meters. The main part of EMAS is an arrested bed, composed of a type of foam concrete with specific mechanical property. When an aircraft rushes into the EMAS bed, the foam concrete is designed to fail under the weight of wheels and absorb their energy. Therefore, the aircraft will be slowed down and safely arrested at a predetermined place. EMAS is mainly made up of setback and arresting bed, as well as steps used for evacuation and service road for vehicles. The arresting bed has the same width as the runway. The height of EMAS can vary in the tens of centimeters range, and the length ranges from tens to 150 meters. In practical application, the length, height, structure, material properties, and installation site will be designed specifically to the various geographical conditions and operating aircraft of each airport. In 2010, a major research and development group from China Academy of Civil Aviation Science and Technology, CAST, began work on the LANZU-1 model EMAS. In order to verify the reliability of foam concrete material and the scientific of its design procedures, CAST set up a large single-wheel facility and developed the computing model of resistance between material and wheel service. CAST even bought a Boeing 737 for 6 large-scale tests to examine the arresting effect and accuracy of design model with different into-bed speeds. In one of the tests, the maximum into-bed speed reached 61 knots, yet the aircraft was totally undamaged. The test result shows that the design procedures of material are accurate and demonstrate the expected arresting effect. Under circumstances of no ordination at all, the maximum error of the original design model is less than 7%, with no damage to the aircraft or injuries to its occupants during the arresting process. In addition, the EMAS components are flame retardant, fire resistant, non-poisonous, and environmental friendly. The arresting bed has passed through the jet blast and fire truck drivable tests. So routine maintenance of the EMAS bed is easy, and the system does not interfere with the rescue work of emergency vehicles when accidents occur. In addition to meeting all FAA and CAAC standards, the surface material has a waterproof coating, giving it outstanding water resistance. The top cover has UV-resistant and anti-aging coating, making it able to withstanding long periods of direct sunlight, which will fit for those plateau airports. In February 2013, LANZU-1 EMAS won the bid of Yunnan Tongchong Airport arresting project. With professional construction organization, the project was finished with high quality and passed inspection of authorities. The LANZU-1 product has been installed at Tongchong Airport for more than 2 years without any adverse effects, has won great acclaim from the airport. LANZU-1 EMAS is the only EMAS has been approved by CAAC, which is an independent intellectual property. CAAC is planning to progressively install EMAS at dozens of domestic airports where the overrun consequences are severe. We are also engaging with other airports in Asia and Europe. We believe that in the future, LANZU-1 EMAS will become the last line of defense for overrunning aircrafts all over the world.